Welcome dear students, we are in the series of the electronic circuit and we are discussing the various components which are used in the electronic circuit. So in today's lecture we discuss one of the important component which used in the most of the electronic gadgets. So the today's topic is the thermistor. We will discuss what is a thermistor, what is the history behind the thermistor, or how the thermistor work. Next we will discuss how many types of thermistors are there. So first we define that what is a thermistor. Thermistor is a resistance thermometer, means a resistor whose resistance is dependent on temperature is known as the thermistor. The term is a combination of thermal and resistor. That's why it is a thermistor. So it is made of metallic oxide pressed into a bead, disc or a cylindrical shape, then encapsulated with an impermeable material such as the epoxy or in a glass. So thermistor is the resistance thermometer where we use the resistors whose resistance is dependent on the temperature. That's why it is called a thermistor. Then it is thermal plus resistor, and it is if we make a thermistor, then we use the metallic oxide, and for this we use also the cylindrical shape or the bead disc in which it is encapsulated, and that material may be epoxy and or the glass. So a thermistor is a semiconductor that contains greater resistance material than the conducting material, and a resistor that reacts to temperature. That's why it is a thermistor, temperature plus resistor. So a thermistor which reacts with the temperature, and the resistor that reacts to the temperature, that is the thermistor. A resistance of a thermistor is dependent on the material from which it is made. So the thermistor is also dependent upon the material which we are using to construction of the thermistor, and their construction material consists of the metallic oxide, binder and the stabilizer. These things we will use: metallic oxide, binder and the stabilizer, that are pressed into a wafer or into a chip with the ratio of composite material determining their resistance or temperature curve. So thermistor is a semiconductor device, and that is used in the most of the electronic gadgets, and that is made of thermal oxide, binder and the stabilizers that are pressed into a wafers or a cut into the chips, and in this manner we can get the thermistor, and we determine the resistance or the temperature curve by using the thermistor. The third thermistor refers to the thermally sensitive resistors that are very accurate and effective sensors for measuring temperature. Because using the thermistor we can measure the temperature. This works like a temperature sensor. So we can use the thermistor for the thermal sensitive devices, and that would where we can measure the temperature. A thermistor is a thermally sensitive resistor that exhibit a precise and predictable change in the resistance proportional to the small changes in a body temperature or in a device temperature. This thermistor just measures the temperature because of the change in the resistance as proportional to the small changes in the temperature. Then we can measure the temperature through this thermistor. So thermistor is a thermally sensitive resistor that are very accurate and effective sensors for measuring the temperature. Moreover, that exhibit a precise and predictable change in the resistance that is proportional to the change in the temperature. How much its resistance will change is dependent upon its unique composition. The material which we are using for the construction of the thermistor, on the basis of that we can decide the change in the temperature. Thermistors are the part of a large group of passive component. It means it is in the types of the passive components of the electronic gadgets, and unlike their active components counterparts, passive devices are incapable of providing the power gain or the amplification to the circuit. So here we on the screen seeing the this is a symbol of the thermistor. Typically, a thermistor achieves high precision within a limited temperature range of about 50 degrees centigrade around the target temperature, and this range is dependent on the base resistance which we are using. So now you see this is the symbol of the thermistor. Sometimes we define in the US and Japan we define this type, and in the resistor there is an arrow that represents the temperature arrow, and here on the right hand side that symbol is used most of the European literature. So the arrow by the T signifies that the resistance is variable because based on the temperature. So the resistance is variable based on the temperature. That's why arrow is mentioned here. The direction of the arrow or bar is not significant because we are having the two type of the thermistor. One is positive and second is the negative. So thermistor history, if we talk about Michael Faraday, that was that explained the concept of the thermistor in 1833, and which reporting on the semiconductor behavior of the silver sulfide. Through his research, he notices that the silver sulfide's resistance decreases as the temperature increases. Means when he was performing the experiment, then he found that the silver sulfide resistance decreases as the temperature increases. So this discovery would later lead to the commercial production of the thermistor in 1930s, when Rubin invented the first commercial thermistor. Since then, technology has improved, paving the road to improved manufacturing processes along with the availability of the high quality of the material for the construction of the thermistor. Now, what are the uses of the thermistor? Thermistors, as the name suggests, temperature measure, used for the temperature measurement as a resistance changes. So, thermistor have a variety of the application. They are widely used as a way to measure the temperature as a thermistor thermometer in many different liquid and ambient air environments. Some of the most common uses of the thermistors are, it is used in the digital thermometers, that is also known as the thermostats. Most of the automobile companies use this automotive application to measure the oil and coolant temperature in the car and trucks. We use the thermistors. Household appliances like a microwave, fridges and ovens also use the thermistors. Other applications are circuit protection. Such protection like rechargeable batteries also consist these thermistors, so that we can measure the temperature as the resistance changes. Now to measure the thermal conductivity of the electrical materials, we use this thermistor. Useful in many basic electronic circuits, and like it is a beginner Arduino starter kit. Nowadays, it is used in the IoT applications as the improved version are coming, so it is used in the IoT as well as artificial intelligence. And temperature compensation, maintain the resistance to compensate for effects caused by the changes in the temperature in another part of the circuit. Now used in the Wheatstone bridges circuit, and there are many application of the thermistor as these are nowadays these are used in the electronic circuits like to just measure the room temperature and other floor temperature as well roof temperature, that we use this thermistor. Now the next is, how does a thermistor work? The working principle of the thermistor is that its resistance is dependent on its temperature. Like as the temperature changes, the resistance will change. So resistance is dependent on its temperature. We measure the resistance as the temperature changes. So we can measure the resistance of a thermistor using an ohm meter. So, if we know the exact relationship between how changes in the temperature will affect the resistance of the temperature, then by measuring the thermistor's resistance, we can derive its temperature also. How much the resistance changes depends on the type of material used in the thermistor and the relationship between the thermistor temperature and the resistance is non-linear. So, the resistance changes totally depend upon the material which we are using and in which device we are using this thermistor, and that relationship between the thermistor and temperature and must it will come non-linear. So, a typical thermistor graph is as this, as we take the graph between the resistance and temperature. As the temperature increases, the resistance decreases. Thermistor with the above temperature graph, we could simply line up the resistance measured by the ohm meter with the temperature indicated in this graph, degree centigrade, and that is defined in the ohms. Like by drawing a horizontal line across the line across from the resistance on the y axis and drawing a vertical line, drawing from where this is horizontal the intersects with the graphs, we can hence derive the temperature of the thermistor. On this manner we can get the thermistor. Now the types of thermistor, here we are having the two types of thermistor. First is the negative temperature coefficient thermistor, that is also known as NTC, and second is the positive temperature coefficient thermistor, that is PTC. Negative temperature coefficient NTC thermistor, positive temperature coefficient PTC thermistor. There are two types of thermistor. What is NTC thermistor? NTC negative negative temperature coefficient thermistor. When the temperature increases, resistance decreases, and when the temperature decreases, resistance increases. Hence, NTC thermistor temperature and resistance are inversely proportional to each other. These are the most common type of the thermistor. The relationship between the resistance and the temperature in the NTC thermistor is as follows: RT is equal to R naught E beta 1 by T minus 1 by T naught. So, R1 is the resistance or temperature T, R naught is the resistance at temperature T naught, and T naught is the reference temperature, and normally we take it as the 25 degrees centigrade. Beta is the constant and is the value is dependent on the characteristics of the materials which we are using. The nominal value of value is taken the 4000 in case of the beta. Now, if the value of beta is high, then the resistor temperature relationship will be very good. If the beta value is high, it means the constant value which is dependent on the characteristics of the material if high, and then the resistor temperature relationship will be very good. A high value of the beta means a higher variation in the resistance for the same rise in the temperature. Hence, we can increase the sensitivity of the thermistor if we take the good value of the beta. So, it will work better as compared to the other devices. The measurement of the temperature will be good. From the expression, we can obtain the resistance temperature coefficient, and this is nothing but the expression for the sensitivity of the thermistor. So, from here we can find out the sensitivity of the thermistor, that is alpha T, and it is clearly seen that it is having the negative sign. So, this negative sign indicates the negative resistance temperature characteristics of the NTC thermistor. We can see the above expression that can measure the sensitivity of the thermistor. Now, if we take the beta 4000 Kelvin and T is equal to 298 Kelvin, then the alpha T is equal to minus 0.0045 per degree Kelvin. This is much higher than that of the sensitivity of the platinum RTD, and this would be able to measure the very small changes in the temperature that can be measured through the thermistor. If we take the good value of the beta, then we can get the good sensitive measurement of the temperature by the thermistor. Now, however, the alternative forms of the heavily doped thermistors are now available, and they are cost effective, but that have a positive temperature coefficient. So, from the expression 1, that is not possible to make a linear approximations to the curve over even the small temperature changes. Hence, the thermistor is very definitely a non-linear sensor. Means output we will get in the form of the non-linear output. So, next type of sensor is the PTC. PTC is the positive thermistors, and then it has a reverse relationship with the temperature and the resistance. Now, when the temperature increases, the resistance increases, and hence these are proportional to each other. Temperature and the resistance are proportional to each other. As the temperature increases, resistance increases, and when the temperature decreases, resistance decreases. Hence, PTC thermistor temperature and resistance are directly proportional to each other. Now, although PTC thermistors are not as common as NTC thermistor, they are frequently used as a form of the circuit protection similar to the function of the fuses. So, PTC thermistors can act as current limiting devices as compared to that of the NTC. NTC thermistors are most commonly used. When the current passes through the devices, it will cause a small amount of resistive heating in case of the PTC, as PTC thermistors can act as current limiting devices. So, now if the current passes through a device, then it causes small amount of the resistive heating. If the current is large enough to generate the more heat, then the device can lose to its surroundings, then the device heats up. So, in the PTC thermistors, this heating up will also cause its resistance will increase. So, in this manner, as the temperature increases, the resistance will increase. This creates a self-reinforcing effect that drives the resistance upwards, therefore limiting the current. In this way, it acts as a current limiting device, or it is used as a protecting the circuit. So, thermistor's characteristics if we define, then this relationship define the thermistor characteristics, that is R1 is equal to R2 e power beta 1 by R1 minus R1 by R2, where we can see these symbols also. R1 is the resistance of the thermistor at absolute temperature, that is T1 0 degree Kelvin, and R2 is equal to resistance of the thermistor at the temperature T2. Beta is equal to constant depending on the material of the transducer, and that is oscillator transducer, and we can see as in the equation above that the relationship between the temperature and the resistance is highly non-linear. So, the relationship between the resistance and the temperature are highly non-linear. A standard NCCC thermistor usually exhibit a negative temperature resistant temperature coefficient of about 0.05 per degree Celsius. So, what are the general selection conditions for the thermistor? When we install a new system or just replacing a device in an existing system, we should consider these key points before we make selection to ensure the desired outcome. So, how we will select the thermistor when we constructing a device? So, general selection considerations, the first point is the base resistance. If we are installing a new application, then we will be sure to select the right base resistance based on the application which we are required. if we are replacing a thermistor, we will be sure to match the current base resistance with the device. The next important point is the resistance versus the temperature curve. If we are installing a new application, determining the correct resistance versus temperature curve relationship, we are replacing a device, we will be ensure that that the information should match with the existing thermistor. So, when we change, then we will take care that the device must be compatible with the previous devices. So, thermistor packaging is another point. Make sure we have to make sure that the selected packaging accommodates the application requirements. Then how much size we will require in the particular application. So, on the basis of that, we consider the thermistor, or we select the thermistor in that manner. Next is the thermistor construction. How we make a thermistor, or two or more semiconductor powders made of metallic oxides are mixed with the binder to form a slurry. How we make a thermistor? You see on the screen that there is thermistor, that is NTP, this thermistor, in this thermistor, if we make a thermistor, then we take the two or more semiconductor in the form of the powder, and then we will make the metallic oxides, and we mixed it into a binder and to form a slurry, and this small drop of this slurry are formed over the lead wire. You see here, this is the lead wire, or the 2 points connected with the lead wire, and from drying for drying purposes, we have to put into the sintering furnace so that it can dry, that drop will dry, the slurry drop will dry, and in this manner we can get the thermistor. During this process, the slurry will shrink into a lead wire to make a electrical connections. So, that connection may be further used to connect the in the circuit or the electronic gadget. This process, metallic oxide is sealed by putting a glass coating on it. It is very thin coating we will put on this slurry. So, this glass coating gives a waterproof property to the thermistor and helping to improve the stability. To damage or just for this, we use the waterproof coating on the slurry. And there are the different shapes and size of thermistor available in the market, and smaller thermistor are in the form of the beads of diameter from 0.15 millimeters to 1.5 millimeters. It depends upon the requirement and depend upon the output. We select this thermistor. Thermistor may also be of the form of the disc and washers, and made by the pressing the thermistor's material under high pressure into the flat cylindrical shapes, also with a diameter of 3 millimeter to the 25 millimeters. You see on the screen there are the various type or the various design of the thermistor as per the requirement. Sometimes it is rectangular shape, it is in the round shape, and it is in the many shape as per the requirement of the gadgets. So, typical size of thermistor is 0.125 millimeter to the 1.5 millimeter. Commercially available thermistors have nominal values like 1 kilo, 2 kilo, 10 kilo, 20 kilo and 100 kilo. So, this value indicates the resistance value at the temperature of the 25 degree centigrade. 1 kilo ohm, 2 kilo ohm, and so on, we can get that the resistance value of the temperature of the 25 degree centigrade. Thermistors are available in the different models like bead type, rod type, disc type. As we see in the diagram, the major advantages of thermistor are their small size and relatively low cost and easy to install. Thus, this size advantage means that the time constant of the thermistor operated in the seats in small, although the size reduction also decreases its heat dissipation capability and so makes the self-heating effect greater. This effect can permanently damage the thermistor. So, to prevent this, thermistors have to be operated at low level of electric current compared to the resistance thermometer, which resulting in the lower measurement sensitivity. So, these are the thermistor. In the next lecture, we will discuss further the types of the thermistor in detail. Thank you very much.